So from our, you can look at the space and there's kind of like several categories of how you can scale. Um, a lot of folks are working on sharding, and it is still a computer science problem, and it's still a really hard computer science problem. And even if you solve it, what you've created is a blockchain that has to separate state. That means that applications that have millions of monthly active users have to figure out how to split those millions of monthly active users, right? That these problems are still very hard to do, and I think the result is going to be slower in terms of latency, but by definition, it's going to be more expensive. That not only does sharding split state, it also splits capacity. So when people talk about raw TPS numbers in a sharded network, if you have 100 shards, each one does, 500 transactions per second, it's not equivalent to a single shard that can do 50,000 TPS, because the price per transaction has to be expensive enough. You cannot do a denial of service on a single shard. So in that sense, these systems are always going to be more expensive than something that we're building. Zero knowledge proofs, I think, are maybe the most promising alternative, but still very early in development, and it's not clear that that they'll be able to do the exact same kinds of computations that you can do in an open, generic, programmable environment. So we'll see, but these are, I think, kind of the most interesting and alternatives out there. You can also do network centralization, and that was demonstrated by EOS. And that seems kind of an easy solution. The thing is that you don't need it. You don't need to centralize the network. What we've demonstrated is that you can actually get the exact same performance of a single machine that's replicated as much as you want without network centralization. So from our perspective, I think even if you could get the exact same performance in a more centralized environment, what we differentiate is that we actually have a truly decentralized network that has performance that is just as good. The layer 2 solutions like ZK rollup and using channels and things like that, we've actually had folks come to us that have been trying to use layer 2 that want an alternative. And the problem with layer 2 is that for a lot of these solutions, when you have a large group of users that are entering and exiting these networks, the setup costs of setting up the layer 2 and tearing it down ends up being a bottleneck in itself. And the number of connections you have to deal with grows kind of quadratically with the set of the network. So it's not you end up with a system that's much more complicated than it needs to be.